Cloud SQL is Google Cloud's fully managed relational database service. It lets you use familiar database engines like Postgres, MySQL, and SQL Server, while Google manages the underlying infrastructure. Your applications continue to use standard SQL, drivers, and connection methods. A Cloud SQL instance is your managed database environment. Google provisions and maintains the compute, storage, and operating system, allowing you to focus your efforts on managing your schemas, data, and queries. Each instance is tied to exactly one database engine type. You cannot mix different engines like Postgres and MySQL in the same instance. Multiple databases within a single instance share the same underlying compute and storage resources. Google Cloud organizes infrastructure into regions and zones. A region is a distinct geographic area, while zones are physically isolated deployment areas within that region. This structure helps protect your workloads against localized infrastructure failures. A basic Cloud SQL deployment runs as a single active database environment in one zone. While efficient, a major limitation is that a localized infrastructure failure in that specific zone will lead to database downtime. To protect against failure, you can enable high availability, or HA. This places a standby instance in a different zone from your primary. The standby exists solely for redundancy and is not used for serving queries while the primary is active. If an infrastructure failure occurs, Cloud SQL automatically detects it and triggers a failover. The standby takes over as the new primary without requiring manual intervention. Your application will briefly lose its connection, but it will automatically reconnect to the new primary. It is important to remember that high availability is not a substitute for backups. While persistent storage maintains your database's operational state, backups capture historical snapshots. If you execute a destructive command, persistent storage will reflect that loss, but backups allow for recovery. Point-in-time recovery, or PITR, goes beyond traditional backups. By using transaction logs, it allows you to roll your database back to a precise second. This is an effective way to instantly recover from human error or accidental data corruption. For read-heavy workloads, you can scale using read replicas. These are independent instances that sync from the primary. You must explicitly configure your application to route read-only queries, such as reports or dashboard data, to these replicas. It is helpful to keep the distinction clear. An HA standby is built for availability and automates failovers to protect against failure, whereas a read replica is built for scalability to handle increased read volume. Cloud SQL supports secure connectivity through private IP addresses. By routing traffic entirely within Google's private network backbone, you avoid exposing your database infrastructure to the public internet. Because serverless platforms like Cloud Run can scale horizontally and open many connections rapidly, you must use connection pooling. This is a critical step to prevent database connection exhaustion. To summarize this mental model, your instance is the managed environment, HA provides availability, backups ensure recovery, and read replicas provide scaling. These components work together to support your application in the cloud.